Hi there, folks. Today we're looking at measures of central tendency and dispersion. And the measures of central tendency, these are the ones that we've done for about 1,000,000 years now. Mean, median, and mode, okay? Remember, the mean is the average. It's when we add them all up and then divide by how many we have. The median is the middle value. That's when we have to put them all in order and then find the one in the middle. And then the mode is the one that appears the most often, okay? So these are used for kind of summarizing data when we talk about measures of central tendency. So again, mean, add them all together and divide by how many we have. It's the average. The median I think to me is the most tedious of all of these because we have to rearrange them, put them in order first, and then start working our way to the value that's in the middle. And remember, if there's a tie for what's in the middle, you have to take the average of those middle two. So you take the mean of those two values. So if there's a tie for the middle, so if there's a tie, we find the average of those two, or find the mean, okay? So just remember that that little nugget. For the mode is an interesting one also because we have to remember that there can be more than one mode. So if there's a tie, we have more than one mode. But in order to be eligible for the mode, it has to at least repeat more than once. So if there's only one of every value, then there is no mode. So that's like an extra little piece attached to that. So if there's no repeats, then there's no mode. Okay, so there's a couple little stipulations that we have to worry about with some of these. Again, median, if there's a tie for the middle, we find the average, and that's our median. The mode, if there's no repeats, then there is no mode. But if there's a tie for the one that repeats the most, then there's more than one mode, okay? And in terms of which of these we tend to use when summarizing data, the mean is like the default in terms of being the best, okay? So I'm going to say default best. So if it says, what's the best measure of central tendency, we default to the mean, all right? The time that we won't use the mean, the time that the median will be the best, this one is the best when there is an outlier. And we're about to talk about those in a moment. Okay? And then the mode, we almost never pick the mode as the one that's the best, unless for some reason almost all of our values are the same. But in that scenario, the median would work out as the middle value anyway. All right. So the mean is by default the best value for measure of central tendency, the best measure. But the median gets used when we have an outlier. Okay. And if you recall, outliers are these values that are much greater than the rest of the data values or much smaller than the rest of the data values. They're so far to one extreme that they almost don't count and shouldn't count, all right? They're way too big or way too small compared to everything else. They're kind of a special case that happened within whatever scenario we're discussing, okay? For example, if I look at these guys, I want to find the mean, median, and mode. I have 8 bowlers and their scores here. And the first thing I might do, like if we're just finding the mean, I would just start adding these together and dividing by how many I have, all right? But since I know I need to do mean, median, and mode, the first thing I like to do is get organized by writing these down in order. So I've got a 104 is the smallest, and it looks like I have another one of those and another one of those. And an easy way to stay organized is just put little marks next to each of these as you get them. See, I'm putting little check marks there, put little dots, or do whatever you need to do to kind of mark. What I wouldn't do is I wouldn't cross them out in case for some reason I need to still read that value. So it looks like I get a 109 next. And then after the 109, looks like the 113. And then the 117. And then the 136. And then that 189. Okay, but make sure you're just keeping a tally of, okay, what have I written down so far? And another nice little check that you can do at the end is you can just count up how many data values you have written down just to make sure it at least matches the total number of data values that you had, all right? And so now from here, I want to find the mean, median, and mode. So the mean, I'll find that one first. You'll also see the mean abbreviated this way as an X with a little bar over it. That also indicates the mean. And in order to do the mean, I'm just going to pull up my calculator here, and I start adding these up. So 104. And most of the work that we do here is done on the calculator. Okay, so that's the addition, and now I have to divide that by how many I have, which was 8. So I get a 122. And notice how I plugged that into the calculator. If you want to try to punch it all in one shot, that stuff divided by the 8, you have to put all that addition in parentheses, or it's only going to divide the last value, okay? So I like to punch in the addition, hit enter, and then divide it by the 8, all right? So that's the mean. The median we start marking off from each end. And then once again, I am not going to cross these out. Maybe I'll underline them, put little dots. So there's the two ends. So it's like I'm crossing those out. But again, I don't cross them out just because I want to still be able to read them. And then I take another one off of each end. And when it's all said and done, I get down to these two values kind of tied for the middle. So these guys are tied for the middle. So what I do is I find the average of those two. So I do the 109 plus the 113 and divide by 2. And here's the thing, you could get away with not actually doing this work. The average of just two values is whatever's halfway in between. And you might be able to look at 109 and 113 and say, okay, the number that's halfway in between those two is a 111. Well, that's what the calculator is about to give me. If I do the 109 plus the 113, again, I hit enter and then divided by the 2, I get 111. So that's my median. So I've got the mean, I've got the median. The last thing I need to do is find the mode. It looks like I have a 104 that repeats 3 times. No other value comes close. So the mode this time is the 104 because that value repeats the most often. And that's it. So mean, median, and mode. All right. The follow-up question to this is which measure of central tendency is the best for this data set? And again, by default, we typically go to the mean unless there's an outlier. So I have to look at this data and say, okay, are any of these data values much bigger or much smaller than all the rest? And hopefully you look at this and say, well, yeah, this guy right here, not even close, right? That 189 is much bigger than the rest, okay? So when I think about that 189, I would consider that an outlier, which means the best measure for central tendency this time is the median. And it's a median because an outlier exists, all right? If you were to find the average, if you were to find the mean without that 189, it'd be a lot closer to the 111. That's what the median does. Because when you think about how we found the median, we cut off the values starting on the outside, so we cut off those extreme values, okay? So we're going to go with the median this time because there's an outlier. Okay. All right, so in this example, it says your grades on 3 exams are 80, 93, and 91. What grade do you need on the next exam to have an average of 90 on the 4 exams? And so basically the situation is this. We're trying to find the mean or the average here, and we have 4 exams total that we're talking about. We have the 80, the 93, the 91, and then one that's yet to be determined, so I'm going to call it X. And those are the 4 exams that I want to find the average of. So I have to kind of take the definition of the mean literally here and say, okay, the average is when I add all these together, even though one of them I don't know, and then divide by how many I have, even though, again, one of them I don't know, there's still 4 exams here. And when that's all said and done, I want the average to equal a 90%. And so now from here, it's just a matter of simplifying this thing. So it looks like I get a 264 plus x over 4 equals the 90. And now this is just a linear equation that I'm going to solve, so I'm not real happy with that division sign. But if I was solving this linear equation, remember it's implied that there's parentheses around this, so I have to undo the division first, so I multiply each side by 4. You could also put that 90 over 1 and cross multiply, but here the 4's cancel, so I'm left with the 264 plus x, and that equals a 360. And now I'm going to subtract that 264 from each side. So I find out that x equals, looks like a 96 over here. So in other words, in order to get the correct average, I need a 96% on that final test, on that fourth exam, all right? And you can very easily check this thing by plugging it back in. So if we want to, we can check it on a calculator. Let's find the average of those exams. I do an 80 plus 93 plus 91 plus the 96, and I divide by how many I have, which is the 4, and it does indeed give me that 90%. So again, we're just kind of working through this thing with the variable in it. It results in a linear equation, okay? If we talk about measures of dispersion, the only one we're going to look at here is the range. And the range is the difference between the highest and lowest data values. We're essentially looking at how many data values are covered, all right? And so if we look at these, this last example here, it says the closing price of 2 stocks for the first 5 days in February are shown. What is the range and mean of each data set? So I'm going to start by finding the mean. And again, you can just say mean, or if you want to abbreviate it with the X with the bar over it, that would also be fine. So I'm just going to add them all up and divide by how many I have. I'm going to do this right on the calculator. And it looks like I have 5 data values. So that one has an average of 32, so that's the mean. Over here, doing the same thing with the next one. Well, I have my calculator pulled up. So I've got the 34 plus the 28, 31. And again, divide by how many I have, which is the 5. So I get an average also of 32. And so each of these has the same average, but now I want to compare the range of the two as well. So let's look at the range of each. The range is just the biggest data value minus the smallest data value. And so in this example, the biggest data value is the 47. And it looks like the smallest data value is the 25. So when I do the 47 minus the 25, it gives me a 22. The next one, again, if I'm looking at the range, it's the biggest data value minus the smallest data value. So in this one, it looks like the biggest data value is the 36, and the smallest data value is the 28. And if I subtract those, I get a range of 8. All right? And see, this is very telling for us, because if I'm looking at this, especially in terms of something like a stock, the average of each of these is the same, but the range of the first one is a lot higher than the second one. Okay? And what that means is that the second, stock B, is a little bit more consistent when it's all said and done. All right. So if we're talking about something like stocks that we're planning on investing in, that first stock varies a lot more. It's up and down. So the extremes of how low and how high it goes are a lot greater than the second one. So the second one is maybe a safer type of stock in terms of its consistency. All right. So they each have the same average, but stock A is a lot less consistent than stock B. All right. And that's kind of what the range tells us. It's telling us how far spread out this stuff is in terms of the smallest value and the biggest value. Okay. The next measures of dispersion we're going to talk about are the variance and standard deviation. And kind of like the range, they're measuring how far spread out this data is. The difference here is the range kind of measures how spread it is based on the highest and the lowest from one extreme to the other. The standard deviation, and that's really the one we're going to focus on here, the standard deviation kind of measures how spread it out it is kind of from the middle of the data, from the mean actually of the data. Okay, and so it's measuring kind of a similar type of thing. It's measuring how spread out we are, all right, but it's measuring it from a different location. It's kind of measuring it from the inside out rather than from one end to the other, okay? Kind of measuring from the center out, using the mean as kind of that center value, all right? When we talk about the variance standard deviation, notice these are the same formula. The formulas are literally identical. The variance is basically a stepping stone towards the standard deviation. It's the same formula, but we take the square root of the thing. And really, the standard deviation is the one that gets used. The formulas that I have here, these are for when you're looking for variance and standard deviation of a sample rather than the total population. And so when you're talking about the population, the variance and standard deviation for the population, the difference in the formula is that it's just an n down here instead of an n minus 1. Most of the time, you're going to use this sample formula, so that's the one we'll kind of use here. But we'll see both of them when we start to plug these things into the calculator, all right? When you look at this formula, just kind of scrolling down here, the x of the bar, we already know that is the mean. That's the symbol used for the mean. X sub n, that's each data value. So when you look at the formula here, notice it's got like x sub 1, the first data value, and then the second data value, and then the third data value, and then the next data value, and the next data value, until you get to the last data value. And that's why it's listed as x sub n. That's why we have these data. We don't know how many data values there are going to be. So really, I just do each of the data values here. And then n is the number of data values that we have. And just kind of looking at this formula in general to kind of show you what's happening here, essentially we're looking at the difference or the distance from the first data value to the mean, all right? And that's what's happening inside this first set of parentheses. In the second set of parentheses, same thing. I'm looking at the difference or the distance between the data value and the mean. And then the next data value, the distance between the data value and the mean. And then I'm squaring all those things and adding it all together. And really, it almost is like a sense of mean itself when you kind of see what's happening here in terms of adding all these together and then kind of dividing by how many we have. We're essentially kind of measuring how far everything is, each of the data values is from the mean. And then we're kind of getting a collective sense of how far we are from the mean as we kind of spread out along this thing, if you want to think of standard deviation that way, okay? We're measuring how far spread out the data is based on measuring from the center, from that mean value, okay? And as we move out, when we talk about things that are normally distributed, as we move out from the mean in increments of the standard deviation, we're going to pick up a certain percentage of our data values. We're going to start collecting those things because typically things will hover around the mean, okay? So taking a look at this example, and we already did this one by hand, finding the mean, median, and mode. Now we're going to find the variance and standard deviation. We're not going to do it by hand, so instead of plugging this into those formulas, really, plugging into the formula is just kind of a tedious task that everyone should be able to do, plug in values in. I'm going to show you how to do this on the calculator. So here we're going to look at the Casio graphing calculator here. And so what we do, we hit the menu button. We're going to go to menu, over to stat, the statistics menu. And if you already have values punched in here, you just have to kind of go through and delete them. So go to the very top one and just start hitting this delete button down here until they're all removed, okay? So that's how you clear out your list. And now I'm just going to punch in each of these values into list one. So here I go. So I've got all those punched in. Now what I want to do is I want to calculate some values. So right here, F2 is associated with calculate. And what I want to calculate, it's called one variable statistics. And it's one variable because we're literally only looking at one thing. We're only looking at bowling scores here. If we were looking at two variables like X and Y, then we could do something like two variable statistics. So right here, one variable statistics. And it'll automatically use a list one for this. And so now when I look at this thing, it gives me more than just the variance and standard deviation. It gives me a whole lot of information here. The very first thing that's listed right here, X with the bar over, that's our mean. So the mean is 122, so I could copy that guy down. And now I kind of go through this list. This next one, that's uppercase sigma. So uppercase sigma there, that is the symbol for the sum. So that's the sum of all the data values, so 976. The next one is the sum of all the data values squared. And now right here, you see this sigma and then with the n and then sigma with the n minus 1. Though that is our standard deviation. This top one, if you think back to that formula, is for population. And this second one is the one that we're using right now, and that's for a sample. Okay, and so when we're looking at a sample, we're going to use this guy. It's the 29.11. And this is lowercase sigma. It's like a little 0 with a hat on it. But 29.11, that is the standard deviation. The thing that's not given here, as we kind of go back through, there's more stuff in this list, and as we scroll down, the thing that's not given is the variance. Okay, so the variance is not on this list, but think about the formulas. Normally, if I do this by hand, I would find the variance and then take the square root to get the standard deviation. So if I have the standard deviation, I just have to square it to get the variance. So we'll cycle back to that. I'll write this value down, and we'll square that in a moment. But I want to point out some of the other things that are on the calculator here. That you've got n, which is the number of data values. But then here, look at this. I've got minimum, I've got maximum, I've got the median, I've got the mode. So the calculator not only finds some of these complicated values, but it'll even sort the values for you and kind of find some of these things that really weren't hard for this example, but they're a pain if I have a lot of data values. Sometimes it's tough to find the median, okay? And so here's the median, here's the mode, maximum, minimum, which makes it easier to find the range. It also gives us the quartiles. If you remember the first and the third quartiles from doing box and whisker plots, those are available here as well. Okay, so now finding the variance, just a matter of going back to this guy and saying, hey, let's take that standard deviation, the 29.11, and I actually wrote down the rest of the decimals here, the 0.62643, and I'm just going to square that. So I square that thing, and it gives me an 847.43. Okay, and so there's our mean, there's our variance, there's our standard deviation for this one. Okay,